Hello, another video in the 21 the second video from the AI disaster recovery series. Now we're looking at failover. Last time we were doing multi-region stuff, which is real cool. Set that up on two different AWS App Runners. So one was in East 1, and one was in West 2. Now we're going to be setting up multi-region, and next will be multi-cloud using GCP. That's the next project. So we're going to build an instant failover with CloudFront and origin groups. So we're going to build automatic failover that switches regions in seconds, not minutes, the same patterns that big companies like Twitch use to maintain uptime during outages. This is very topical given the outages that have been happening recently with very big spaces like US East 1. So yeah, super good to understand this and have a project around it. So 30-second summary: when your primary server goes down, how long does it take for traffic to switch to backup? With traditional DNS-based failover, you're looking at minutes of downtime while DNS records propagate across the internet. During the 2021 fast CDN outage, sites like Twitch and HBO Max went down for nearly an hour, costing millions in revenue. This is why companies like DAZN, streaming sports in 200 countries, and Twitch use edge-based failover. CloudFront origin groups detect failures and route traffic to healthy servers in seconds, not minutes. Failover happens at edge locations worldwide. No DNS changes, no manual intervention. So you'll build this exact pattern, a CloudFront distribution that automatically routes traffic between two AWS regions. When one fails, traffic switches instantaneously. When it recovers, traffic returns automatically. This is how production systems that serve billions of requests maintain uptime SLAs. Cool, so what you'll build. So you've got an edge function, edge location, up here, and you've got US East 1 and 2. We're going to be setting US East 1 as the primary, and if a fail happens, then traffic gets rerouted to US West 2 to the same URL. So in this project, you'll configure CloudFront origin groups to provide automatic failover between AWS App Runner services in US East 1 and US West 2. By the end of this project, you'll have a CloudFront distribution with origin failover configured, automatic failover that switches regions in seconds when the primary fails, automatic failback that returns the primary when it recovers. Secret mission: if we do that, we will. If you do that, and we will do that. CloudWatch alerting that notifies when failovers like the ones we set up occur. So prerequisite: this is building on the deploy multi-region project. You'll need two AWS App Runner services running. So that's one in East 1 and one in West 2. And we do walk through it, so it is a prerequisite, but we do walk through it, but definitely do the project. If you really don't want to, you can walk through the setup guide in this project. So if you're new to CloudFront, CloudFront is AWS's content delivery network, CDN. It caches and serves content from 400 plus edge locations around the world, reducing latency for users everywhere. But CloudFront isn't just for caching, it's also a powerful routing layer. Origin groups let you define primary and secondary locations with automatic failover when the primary becomes unhealthy. DAZN uses this exact feature to ensure live sports streams keep up when backend systems fail during traffic spikes. You don't need any prior CloudFront experience. This project teaches you how origin groups work and how to configure failover that happens in seconds. And if you're not sure about this project, if it's right for you, you can check using the Ask feature here, whether it is. We'll do this quiz at the end. We're going to walk through the high touch step-by-step guidance. There are options for these as well. If you feel more confident with this sort of stuff, you can totally go through and do it with less guidance. We will walk through this one today. And I have done project 1, but if you haven't, then there's a big long set of steps there for setting that up. So yeah, you can go ahead and do that if you want to. no, if you haven't done project 1. Cool, so what are the prerequisites you do need for this project? This project requires setting up App Runner, say 2 App Runner services that host the same web app. I have App Runner services running in US West 2 and US East 1. These services are needed because my failover will switch between them. Cool. So 2 App Runner services hosting the same web app, and they're running in West 2 and East 1, and I need these because failover will switch between them. So step 1, we're going to create a CloudFront distribution. Time to build the same failover pattern DASN uses in sports live streaming. You'll set up CloudFront with an origin group that automatically routes traffic to your secondary region when the primary fails. This is how big production systems work. What is CloudFront? CloudFront is AWS's content delivery network. It has edge locations around the world that can cache and serve content closer to users, but CloudFront isn't just for caching, it can also route traffic. These servers are called origins, and automatically switch them when another one fails. Cool, so in this step I'm going to create a CloudFront origin group by gathering the AWS App Runner domains and setting them up as origins. CloudFront is important because it allows failures to be, allows unhealthy instances to be detected, then switched out for a secondary healthy one. Cool, so what are we doing in this step? In this step I'm going to create a CloudFront origin group. CloudFront is important because it allows unhealthy instances to be detected, then switched out for a secondary healthy one. Cool, so I'm going to gather our app URLs. So before creating the CloudFront distribution, let's grab the app URLs for both App Runner services. Cool, so let's head over to the console. I have it open over here in this Chrome profile. So what I'll do is I'll put this on the side of the screen and this one over here. Cool, so let's go to AWS App Runner. Just type that in. Cool, so we can see this service here. Because I've done the previous project, it already exists. We can click on this. I'll just unpause this or resume it. It'll be ready by the time we get there. We can select this domain. It's not going to run because it's paused, but the domain will still be correct. So we can copy that. We can paste it in there. Cool. So we can now switch to US West 2. And we can, so this one is running. Go to the App Runner service. We can click this. This one does pop up, and see this one's failing to fetch because it was down. I'm just putting it back up now, but we'll copy this and then chuck it also here. Close that now. Cool, so we can go back to the console, and then we can go over to CloudFront. These are 2 old distributions. Don't worry, you won't have these. haven't deleted them. Cool, so we'll click Create Distribution. And this is a very important step. This may look very attractive given it's free, which is good, but unfortunately what we have to do is go with the pay-as-you-go plan. This doesn't allow CloudFront to operate with origin groups, which is our goal. So yeah, we will have to go with not that one, this pay-as-you-go scheme, which would only cost, I mean, a few cents maybe if you just close it afterwards. But it's just unlocks something that we don't have in the free tier. Cool. So we will click next, and we'll type in a distribution name. Single website or app is good. We'll skip this. This is a Route 53 domain, so a different thing to the domains we already have. And then we'll click next here. So we're going to do other because we're not, our origin is not some like predefined thing here. It's not, there's not AWS App Runner, it's not VPC, not API Gateway, none of these. Cool. So now we can enter our copied domain into there. It might, see, this is a bit of a tricky thing. It's gotten rid of the HTTPS, which is correct at the front, but it hasn't got rid of this extra backslash, and it'll pop up as an error when we try to submit it later on. So yeah, definitely get rid of that backslash when we talk about that here. I think we do at least. Yep. Cool. So if you're getting that, get rid of the backslash at the end. You'll get a little red pop-up. What is an origin in CloudFront? An origin is where CloudFront fetches content when it does not have a cached copy. Your origin can be an S3 bucket, an EC2 instance, a load balancer, or in our case, an app runner service hosting the web app. When users request a CloudFront URL, CloudFront either serves cached content or forwards the request to your origin. Okay, configure security settings. So we'll scroll to and then review the security options available. Click next. And then we'll click next. And this is where you get the little pop-up after you click this, that this domain would have a slash at the end. So yeah, but we didn't have it there, so we're all good. All right. So we have our CloudFront domain here. So we'll just paste that in, and this is what everyone that would theoretically use this web app would go into, and then they would get routed to either east or west depending on what's up. If the primary was up, then they would go to that. If the primary is down, then then they would go to secondary, which is west. Yeah, that's that. Cool. So I'll upload a screenshot of this. What is the origin you configured for your distribution? I created a CloudFront distribution with the origin is my CloudFront URL is created it with the two AWS App Runner services, US East 1 and US West 2. The origin is can actually go and and origin is where CloudFront fetches content when it doesn't have a cached copy. CloudFront fetches from doesn't a cached copy. My CloudFront URL is, just paste that in there. Awesome. So what is the origin you configured for your distribution? I created a CloudFront distribution using the two AWS App Runner services, US East 1 and US West 2. And origin is where the CloudFront fetches from when it doesn't have a cached copy, and my CloudFront URL is, should be a space there. Cool. Alright, configuring origin group for failover. Your CloudFront distribution is deployed with your primary origin. Now let's add the secondary origin and create an origin group that enables automatic failover between them. In this step, get ready to. We're going to add a secondary origin, US West 2, create an origin group with failover criteria, configure cache behavior to use the origin group, and test your CloudFront distribution. So what are we doing in this step? In this step, I'm going to add a secondary origin and create an origin group with failover criteria. Configure cache behavior to use the origin group and test the CloudFront distribution. Origin groups enable failover by grouping multiple origins, one specified as primary. Cool. What are we doing in this step? In this step, I'm going to add a secondary origin and create an origin group with failover criteria. Origin cache, configure origin cache cache behavior to use the origin group and test the CloudFront distribution. Origin groups enable failover by grouping multiple origins, one specified as primary. Cool. So now we're going to add the second origin. So now add your US West 2 App Runner service as a backup origin. Click on the distribution to open it, and then go to the Origins tab. I think I was here, but click on Origins there. Click Create Origin. We're going to put in the domain that we had here. Make sure to get rid of that slash at the end. We can name it secondary US West 2. I think that should be good. Click Create Origin. You should see a success message confirming the secondary origin was created. You now have two origins. Very good. Now we're going to create an origin group for failover. Origin groups enable automatic failover. When CloudFront detects the primary origin is unhealthy, it automatically routes to the secondary. So to stay on the origin tab of your distributions, click the origin group, create origin group. So we'll select both that'll be the east and then the west. So there's east 1 and west 2. Click add on both of those. And we'll configure it with the name of failover group. And then we'll select 404, 500, 502, 503, 504. And so what's happening here in the failover criteria is we're specifying what, it kind of says there, select the origin errors to use as failover criteria. If our page ran into a 404 error, or a 500 error, or 502, 503, 504, it's going to detect that as unhealthy and then reroute accordingly. So yeah, you can configure this differently depending on what you want, but this is how we're going to set it up. This is a pretty common thing to set up. And now we're going to create origin group. We should see a success message here. And I will note that this does need to deploy. So any changes you do at any point need this, for them to have guaranteed success, this needs to say, it'll say last modified and a date and time, not a deploying symbol. So what is an origin group, and how does failover work? So an origin group bundles two origins together, a primary and a secondary. CloudFront always tries the primary first. If it gets one of the error codes specified, like we just talked about, in our case, the ones listed here, it immediately retries the same request against the secondary origin. This happens at the edge location level, so failover is nearly instantaneous. So no DNS propagation like traditional failover. So if you had this set up like it says there with a traditional failover, then you'd have to go spin up another instance, or not spin up another instance, sorry, like switch to it and route traffic accordingly, when traffic is already kind of has the opportunity to be routed there regardless. So there's no time at all. It's pretty much instantaneous. So why include a 404 in failover criteria? This is a subtle but important detail. When you pause an App Runner service, it returns a 404, not a 500 or 5xx. If you only selected 5xx errors, 500, whatever, these ones, CloudFront would keep trying to pause primary and never fail over. So including 404 ensures CloudFront switches to the secondary when the primary service is unavailable for some reason. We'll be pausing it as our demo, as to check that everything is working. Cool. I'll take a screenshot of this. What failover criteria did you configure and why? I created an origin group with US East 1 and US West 2. The failover criteria includes, what we got? We got 404, 500, 501, 502, 503, 504. Because these are the errors we are concerned about. Say failing over for, e.g. when any of these happen, we want the service to be detected as unhealthy and switch. What failover criteria did you configure and why? I created an origin group with US East 1 and US West 2. The failover criteria includes a list of errors there, and Failover 4. Because these, we're doing this because these areas are, these are the areas we're concerned about failing over. So failing over, I can drop the 4 there. E.g., when any of these happen, we want the service to be detected as unhealthy and switch. Cool. So we're going to update cache behavior. Now point the default cache behavior to your origin group. So go to the behaviors tab and distribution. We're going to click there and click edit. And then we're going to select a failover group. Scroll down and select save changes. Cool. So this can take a few minutes to deploy. So yeah, up to between 2 to 5. It's pretty common. So yeah, that shouldn't take too long. And then once we've done that, we can, because if we go to this now, it'll be not on, more than likely. Yeah, so this will be populated eventually, well, in a couple of minutes, once that's finished deploying. So yeah, we will sit tight and wait for that to deploy. Cool. So it looks like that's deployed. So if we go to over there, go to our address here. Very good. So we now see US East 1, and US East West 2 responses there. I think we can go to that as well. Yep. So this is, we know this is being served from East 1, which is exactly what we want because it's the primary. We'll get on to testing shortly, but we see that. So very good. This confirms CloudFront is working and routing traffic to your primary app runner service. There's 2 tabs here. It's working. Need help? Yeah, definitely recommend talking to the community or going using the ask feature here to ask questions if you get stuck. The community's great. Certainly, all your answers will be there. The Discord server you can go to. But yeah, basic stuff is distribution not ready. May take a while for this. This did take almost 5 minutes to go through. Domain names might not be correct. Origin group not selected. Browser caching. Little tip: you can go to invalidations here, create an invalidation, and do this, which invalidates everything, every bit of cache. You can create that, and that'll go and cache things if you think that could be an issue. So definitely an option to try if it's not loading. It doesn't take very long, only 20 seconds or so, maybe less. Cool. What response did you see when testing your CloudFront URL? I tested my CloudFront URL and saw the US East 1 web app loading. This confirms that CloudFront is routing to the, you can see that's finished there, so that would have invalidated all the cache, and now when I visit again it'll completely re-go again. Cool. It's routing to the primary host because it is, in brackets, because it is up. Primary host US East 1 because it is, say, healthy, not 5xx/4 error. Cool. So what response did you see when testing your CloudFront URL? I tested my CloudFront URL and saw the US East 1 web app loading. This confirms that CloudFront is routing to the primary host US East 1 because it is healthy, so not either of those two failovers. Cool. Step 3. Test failover and failback. Alright, so your CloudFront distribution is live. Now comes the exciting part. Let's simulate a regional outage and watch CloudFront automatically fail over in seconds. Then verify it fails back when the primary recovers. This is what Twitch's engineers do when they validate Sage Origin Backup. That's the system that maintains 99.99% availability. Cool, so in this step, get ready to pause the US East 1 App Runner service to simulate an outage, verify automatic failover to US West 2, resume the primary service and verify automatic failback. So what are we doing in this step? I'm going to test failover. In this step I'm going to test failover by pausing the US East 1 AWS App Runner service to simulate an outage and verify failback. Say then I will verify failback by resuming the US East 1. This tests that CloudFront is able to detect a, because this is called a 404 error, and fail over, then fail over to run on US West 2 secondary host. This verifies, well, this should happen almost instantly. What are we doing in this step? In this step, I'm going to test failover by pausing the US East 1 AWS App Runner service to simulate an outage. Then I will verify failback by resuming the US East 1 AWS App Runner service. This tests that CloudFront is able to detect a 404 error, then fail over to run on US West 2, which is the secondary host. The 404 error on the primary host. Then fail over to run on US West 2, which is the secondary host. This should happen almost instantly. Cool. Awesome. So we're going to navigate to the desktop here. We should go to AWS App Runner. Open this up. Make sure you're on US East 1, the region. Check with the region selected on the top right. So I'm not, that's good, I checked. Yeah, but you can select different regions up here, and we're working in, well, we're going to disable the primary, which is US East 1. If we disable the secondary, nothing would actually happen, because that would, until US East 1 failed. If they both failed, then, well, it would go down. But, yeah, US East 1 is our primary, so if US East West 2 failed, which is what I was about to do, if I didn't read that line, then, yeah, we wouldn't see anything. But, yeah, we can go and pause this Pause the primary service. Pausing simulates a regional outage. The service stops responding, triggering a CloudFront failover. So if we go up here into Actions, we can select Pause. So it's asking us, pause service multi-region app east. Your service will be unavailable while paused. You can resume the service once the pause operation is complete. Click Confirm to proceed. Cool. So once that happens, once this finishes pausing, we will be able to we'll be able to head back over to our to this page here, which, as we just talked about, is currently on US East 1, and we should be able to see it running. So it's paused now. So hypothetically, when we refresh this page, just go back to over here. So if I go to CloudFront, cool, so we just go to the same domain. Cool, so we can see East 1 failed to fetch, and we go /API/region, this should be West. Very good. So we know we took East down, West went up, and there was no delay there. So that's what we want, because it detected a 404 error, and then so it detected 404 error, and then once it saw that, it put the traffic to West 2. So why use pause to simulate an outage? Pausing is the safest way to simulate a regional failure. The service immediately stops responding, returns a 404, but your configuration stays intact. You can resume it in seconds. In a real outage, the region might be completely unreachable. Pausing gives us a control way to test the same scenario. What happens when an App Runner service is paused? When you pause an App Runner service, the service stops running immediately, returns HTTP 404 for all requests. No compute charges accrue while paused. You're not paying for idle resources. The service configuration, deployment, settings, and custom domains are retained. Resuming takes about 30 to 60 seconds to spin back up. So we'll do that. So wait for CloudFront to detect failure. CloudFront health checks. Use the ask feature here if we want to discuss what a health check actually is. This is where we scroll a little bit, I think. So CloudFront health checks run continuously. When the primary returns errors, CloudFront routes to the secondary. Wait approximately 30 seconds for CloudFront to detect the failure, and then once CloudFront caches health status, so give it time to recognize the change. So how does we click this to open the ask chat here. So how does the CloudFront check if an origin is healthy? Is it active or passive? And it's given us a good answer there. So this is active monitoring strategy. It explains it. Very good. So now verify CloudFront has automatically switched. We did that. Refresh your browser. You should see the with the CloudFront URL. You should see hello from West 2. If we do, very good. This is the same thing, which is not in the API origin. So we see only West 2 getting a response. It is working. Very good. So what happened when you paused the primary service? I paused the US East 1 service in CloudFront. and CloudFront. Redirected traffic to US East, no, US West 2. The response changed from US East 1 to hello from US West 2. Cool. So we're going to verify CloudFront monitoring. You can also check CloudFront monitoring to see the failover in action. Go back to CloudFront, check your distribution, select monitoring, and look at the origin error state metric. You should see errors from the primary origin. Automatic failover happened at edge in seconds. No DNS propagation, delays, no manual intervention required. How good. So why is this faster than DNS failover? Traditional DNS-based failover using Route 53 health checks requires DNS records to change and propagate globally, which takes minutes. CloudFront origin failover happens in edge location, at the edge location level. When the edge server gets an error from the primary, it immediately retries with the secondary on the same request. Users experience a slightly slower response to origin requests, but there is no propagation delay. So, setting it up is a little bit more, but overall, you're not going to get that minute or two between when another one has to get spun up. Cool, so we can resume the service. We go back to AWS App Runner. Click into here, go to resume. Should take a minute. Wait for the service to start. The App Runner service needs time to restart. Wait for the service, change to running. Typically takes 1 to 2 minutes. You can monitor the progress in the service activity bar over here. So we'll see a green thing pop up in a minute. And then we'll wait for CloudFront to do the health check, which should be pretty quickly, or pretty quick. Once the primary is healthy again, CloudFront will automatically prefer it. Wait for approximately 36 seconds for the service to start running. Or after the service is running, CloudFront needs time to detect if the primary is healthy again. So how does CloudFront know when to fail back? CloudFront doesn't have a health check in the traditional sense. It evaluates origin based on origin health based on the response it receives. Once your primary starts returning responses 200, okay. Instead of errors, CloudFront automatically prefers it again. This is called passive health checking. CloudFront learns from actual traffic rather than sending probes. Very good. So we're going to test fallback in a second. Verify CloudFront has returned to the primary origin. Verify your browser tab with the CloudFront URL. You should see now see hello from US East 1 again, your primary response. See, I think it's still resuming. Haven't got anything there yet, but we're supposed to see both up again. And when I do API region, it'll go back to East 1. Cool. Cool. Okay, that's running. There you go. So we're back on US East 1. It's connected again. Cool. What happened when you resumed the primary service? I resumed the US East 1 service and CloudFront preferred the US East 1 primary service. The response returned to to right, of course. This confirms that the CloudFront setup is CloudFront is set up correctly, or CloudFront failovers are set up correctly. Cool. So what happened? I resumed it. It popped back in US East 1 because it's a primary service, and it says that, and that means CloudFront failovers are set up correctly for this. So we can review the timeline in monitoring. So we can jump back to App Runner, or not to App Runner, sorry, to CloudFront. We'll click on our distribution here. We'll go to monitoring. I think it's this one. And we can have a look about some stuff there. Yeah, we can look at a bunch of stuff. There's heaps of things you can monitor here. But yeah, we can look at requests, data transfers, error rates. It's a list of stuff there. So the 400 errors were when we closed it. So that makes total sense. We see a spike, so the error rate says good. So we expect to see normal traffic, a spike in errors when we pause the service, traffic shifting back to the origin after we resume service. This monitoring data shows exactly how long failover took and when traffic was returned to normal. Cool. So what should you see in the monitoring graphs? The monitoring graphs tell the story of your failover test. Request graph shows consistent traffic throughout the test. Error rate spike, we see over here. When you pause US East 1, errors spiked briefly. The failed request to the primary. Error rate drop once failover kicked in. Error dropped. Successful request to the secondary. Returned to normal. After resuming, traffic smooths returned to the primary. If you see a clean pattern like this, your failover is working as designed. Cool. This is what we see, which is good. Makes plenty of sense. We see it go down to 0 again after an initial spike. Very good. So now we're going to do the secret mission. Build production alerting for failover events. So letting us know about this sort of stuff happening through email. Automatic failover is great, but how do you know it happened? Devs and engineers don't wait for Twitter complaints during the Champions League match. They get instant alerts the moment something goes wrong. By now, you've built an automatic failover between two AWS regions. In the secret mission, you'll add the final piece of production-grade infrastructure, automated alerting. So you'll set up CloudWatch alarms that notify you via email, the instant CloudFront detects and origin failure. The same observability pattern used by teams serving billions of requests. Cool. In the secret mission, you're going to build a production-grade alerting system using CloudWatch and SNS. The same observability stack AWS customers use to monitor billions of API calls daily. When your primary origin fails and CloudFront switches traffic to the secondary, you get an email notification within minutes. No more discovering outages from Twitter complaints. Why is alerting crucial for production systems? Automatic failover is great, but you need to know when it happened. Maybe the primary region has a real issue and needs that investigating. Maybe it's a false positive, maybe there's a pattern. So without alerting, you're flying blind. So in the secret mission, we're going to create a CloudWatch alarm, set up an SNS service-centered email when errors exceed a threshold. and test your alerting by triggering a failover. So what are we doing in the second mission? I'm going to build alerting with CloudWatch and SNS2. Send an alerting alert email when a failover is triggered. This is important because automatic failover alone can hide real issues. We will go on and test this. A real failover. So what are you doing in the secret mission? I'm going to build an alerting. To build alerting with CloudWatch and SNS to send an alert email when a failover is triggered. This is important because automatic failover alone can hide real issues. We will then go on and test with a real failover, with a failover. Cool. Let's head to AWS console. We'll go to So make sure we're in US East 1. Cool. Okay. So go to alarms, go to all alarms. We'll create a new alarm. What is a CloudWatch alarm? A CloudWatch alarm watches a metric over time and triggers actions when it crosses a threshold. Think of it like a smoke detector for your infrastructure. It monitors continuously and alerts you when something's wrong. So we'll select a metric, or click select metric. We'll type CloudFront into here, press enter, and then we'll select CloudFront and then per distribution metrics. And I have quite a few different distributions here, but we'll make sure to get the right distribution ID. So I'll just head back to this, just make sure give the right one. So E2V. So we're only interested in this stuff. So we'll go with this one for the pause that we're going to be seeing when it switches. So select metric. What is 4xx error rate? 4xx error rate measures the percentage of errors of requests that receive 4xx error response. When CloudFront can't reach your primary origin, this metric spikes, exactly what we want to alert on. Cool. So found the metric, can't find it. There's some more information about figuring out where it is there. Configure alarm conditions. So yeah, we can set a threshold that triggers the alarm. For select average, for period, select 1 minute. I'm going to change heaps, but make it a bit easier for us to see it when we're testing in a second. Under conditions, keep static selected for threshold type. For whenever 4xx error rate is, select greater, and then 50. Cool. Click next. Keep that alarm selected. Do create a new topic into that, and then we'll to an email we want to send this to. Create topic. Cool. Good to go. And then we'll select next. give our alarm a name. What is SNS? That's what we just set up. SNS, Simple Notification Service, is AWS's messaging service. It can send notifications via email, SMS, HTTP endpoint, Lambda functions, and more. Here we're using it to send you an email when the alarm triggers. Why create an SNS topic instead of just an email? An SNS topic is like a broadcast channel. You can subscribe multiple endpoints, emails, phone numbers, etc. to the same endpoint, same topic, sorry. This means when you add more notification methods without, you can add it later on without modifying the alarm. So we'll name the alarm call it that because I've already got alarm with that name. Go alarm description. You can scroll down and click next. And this just gives us some information about our alarm which is set up. We'll just click create. Cool. And you may very well get something which says that there is some stuff waiting for verification. That's completely fine. I will verify that quickly. Yeah, you'll probably get a pop-up up there, or sorry, up here. We'll have verified that. That should be this bottom one. Cool. Yeah, the email looks like this. Cool, we'll upload a screenshot of this alarm. What alarm and notification did you configure? I created an alarm on the 486 error rate metric with CloudWatch and SNS. The SNS topic will notify the specified email when the threshold exceeds 50. What alarm and notification did you configure? I created an alarm using the 486 error rate metric with the CloudWatch and SNS. The SNS topic will notify the specified email when the threshold exceeds 50. Email confirmed. Didn't receive an email. We got one, so we're all good. Cool. So we can go back to App Runner again. Probably just keep these open at this point. Go to App Runner. Again, this one's running. We're in US East 1. And we can pause it. So why test alerting before going to production? Testing your alerts is critical. You don't want to discover if they're misconfigured during a real incident. By deliberately triggering a failover, you verified the entire chain works. CloudFront detects the error, CloudWatch alarm triggers, SNS sends notification, you receive the email. This gives you confidence that when a real outage happens, you know about it. Cool. So, yeah, we will just wait for this to finish pausing, and then we can have a look at the alarm that we set up. Cool. So that's finished. That's paused now. If we go here, we should see this top one failed to fetch, which is what we want. And then if we go to CloudWatch, we go to all alarms, we go to this one, you can see there a higher than a percentage score of higher than 50. So at this point we would get an email, and it's going to tell us that there is there is an outage, and then that it's switched over. So that's, yeah, perfect, exactly what we want. So I received an alert, that's great. If you didn't, there's some things here you can try. Yeah, and then we can resume the primary service as well. We'll jump back to App Runner. Make sure we're in the right region, and then resume. After the service is resumed, you'll receive another email indicating an alarm has cleared. Cool. Just take a screenshot of this. My email. How did you verify your alerting worked? I tested the alarm by pausing the instance for the AWS App Runner and US East 1. After waiting, I received an email showing information regarding an alarm going off for the outage triggering. This confirms that the alarm was set up correctly. I will note sometimes it does take a bit of time for the email to come through. I got quite fortunate then, but in the past it's taken 5 minutes or so. Yeah. Mission complete. You've built a production-grade infrastructure, automatic failover plus automatic alerting. Your team will now know the instant something goes wrong, and the system will handle it automatically while you investigate. This is how companies like Twitch maintain super high uptime SLAs, not by preventing all failures, but by detecting them instantly and recovering automatically. DAZN uses the exact same pattern to live stream sports to millions of people. So you've learned to create a CloudWatch alarm, set up SNS, configure automatic alerts that notify when failover occurs, test your alerting system by triggering controlled failover. So taking it further into production, multiple notification channels, so you can do Slack, PagerDuty, Opsgenie, different severity levels, so 25%, 50%, whatever. We just did one, which was just full. Runbooks and the alarm hit descriptions, dashboards showing failover history, automated redemption, and then Lambda functions that fix. So that's what it is, Lambda functions that attempt fixes. Cool. So if you're going to clean up resources, then you can do that. CloudFront only. You can pause some stuff. So that's AWS App Runner. You can disable and delete CloudFront distributions. You can go to click disable and CloudFront here. You can go there and full screen it and click disable. Yeah, if you want to remove everything, there's instructions here to do that as well. I'll be keeping stuff because there's another super exciting project in on multi-cloud using GCP to take this even further. That's a wrap. This is what we learned overall: how CloudFront origin groups enable automatic failover between regions, why edge level failover is faster than DNS-based failover, no propagation delays, how to configure failover criteria, how CloudFront automatically fails back when primary origin recovers, how to use CloudFront monitoring, and we can do a little quiz at the end. So what is the primary role of CloudFront in this project's failover pattern? To route traffic between multiple backend servers, origins, automatically switch them, to host AWS, to provide DNS. For this one, how does CloudFront origin failover compare to traditional DNS-based failover in terms of speed? faster because it happens in the edge location, avoiding DNS propagation delays. Sounds right to me. How does CloudFront determine when to automatically fail back to the primary origin after it has recovered? Prefers automatic primary once 200 OK response. Looks right to me. What is the main purpose of creating an origin group? To reduce latency, to combine multiple content types, to manage different caching policies, to enable automatic failover between primary and secondary origin. Sounds right to me. Why include HTTP 404 in a failover criteria? Paused app. Looks right to me. What happened when App Runner service is paused as described in the project? Automatically scales down to 0. Service enters read-only mode. Service stops running for all requests. The service continues running but reduced capacity. I think it's this one. Cool. Awesome. So we can click mission accomplished. This very nice animation that was done. Love the photo of Maximus there. Yeah, that's the second project in the disaster recovery series with AI. Yeah, super cool. Yeah, super excited to keep going with the series and go into multi-cloud next with GCP. Thanks guys for watching. I hope you enjoyed following along. See you in the next one.